Okay, hello, welcome to my channel. In this video, we want to find a solution to this question. So we have that if we have the integral, the indefinite integral of x times the square root of 2x plus 3 dx is a constant plus x over 3, then this minus 15 of that, right? Then we should find this the sum of these terms here, a plus b plus c minus d, right? So this question is from the JEE indefinite integral math questions, right? So now this is how they represent their questions, where they give you the general structure, okay, of how your indefinite integral should be, and then they ask you to maybe compute either the sum, the difference, the product, or whatever operations on the arbitrary constants. So the first thing is to take note of how the questions are, or how the integral appear. Then you are going to try to make sure that your own solution have this same structure, right? Good. Okay, so you won't just be working on this carelessly. You are going to be looking at the solution as you are working to see if your own answer is going to have this form, right? Okay, that's very nice. Now let's see how we can look at this. So let's put it down here, the integral of x times the square root of 2x plus 3, and then we can put the dx over here. Okay, great. So now looking at this question, for a regular integral student, we usually approach this kind of question by making a use of, okay, we just look at under these integrals and we want to have just one single term there. We are going to say let u be 2x plus 3. Well, that is going to work out very nicely, right? There is no problem with that. But this way, if you use that method, right, or that approach, we will find it harder, a lot more difficult to get this particular structure or this particular form, right? So it is a lot more easier by using integration by parts. Yes, we can use integration by parts for this, and this is how we are going to look at it. Well, I'm going to start off by saying, let's, for integration by part, we need to choose a function to differentiate and a function to integrate, and I'm going to be doing this using the DI method, right? So okay, so I'm going to start off by writing out a D here. This D stands for the function we want to differentiate. So I'll choose the function and write it under it. This I stands for integrate. And then I will not forget to put my addition sign, my subtraction sign here. And you can keep on alternating as much as possible. But most times we do not need more than two. Sometimes we may need, but just as we may need anyway. If we need it, I will continue. Now, this is how we are going to work on it. We will choose each of these functions. Which of them should we differentiate and which of them should we integrate? Well, I'll choose to differentiate x, even if it's a lot more difficult to integrate this one compared to integrating x, but I'll choose to differentiate x, alright? And then we choose to integrate the square root of this. In fact, let me put it down as in its index form, that is 2x plus 3, right? And then I'm going to put the square root as 1 over 2 power, right? Great. After choosing the functions to differentiate and integrate, the next row here we are going to differentiate and integrate respectively. So when we differentiate x with respect to x, we're just going to have 1, right? Because we are looking at dx here. And then we are going to integrate this over the x variable. Good. So you just notice that this right here is a linear expression inside there, and then we are raising it to just a power, a constant power. When we have this kind of integral, right, where we have, let's say, ax plus b raised to some power, let's say c, the integral will give us 1 over c times 1 over a times, c plus 1, right, times x plus b raised to the power of c plus 1. That is to say, you will add 1 to the power and then divide by the new power, and then you multiply by 1 over the coefficient of this x, and then you put down the original stuff. Just check out how we can find the integral of this form, of a function of that form, right? So this is going to become, well, when we add 1 to 1/2, you're going to have 3 halves. So I'm going to divide this right here by 3 over 2, which means I'm going to multiply it by 2 over 3. Is something as that. And then this right here is the coefficient of x, because this is just a linear term. So the coefficient of x is just 2. When we are differentiating, we multiply by the coefficient, but since we are integrating, we are going to divide by that coefficient, and then we are going to put down the original thing, 2x plus 3, and as well, you remember we added 1 to the power. That means we're going to have 3 halves, right? Good, that is very nice. So that's what we get from the table, and that tells us that this function, the integral here, can become the integral of x times the square root of 2x plus 3 dx would become, well, let me clean this up a little bit, and let's continue over here. Okay, so this is very nice. Now look at this. When we are done with the table like this, right, what we do is to multiply this diagonal with this one, like multiply this diagonally, this term and that term, right, and then keep in mind the sign in front of it. Then we also multiply these two terms together, right? And when we are done multiplying these two terms after this one, we will integrate this product. The product of the row we integrate it, then the diagonal we just keep it as the first part of the answer. So this is going to be x times that. In fact, we're going to have 2 over 3 times 1/2. In fact, we're going to have 1 over 3 right there, right? 1 over 3 times 2x plus 3 raised to the power of 3 halves, right? And then minus this times that, right? Remember, that is going to be inside the integral 2x plus 3. Then raise it to the power 3 halves, and then dx over here. So you notice what we've done there. We multiplied this with that, we kept it out here, and then we multiplied the last row, right? When you multiply the last row, you integrate that product. Okay, that's nice. Now you see what we have. Well, here is also something else to integrate. I would have continued here, but there's no point. I will just do it here at once. Now, that means we have this first part. We are very okay with that. But we still have to integrate this one, which has, in fact, the same structure as what we did earlier, just that this power has been increased to 3 halves. Okay, so that means this is going to be, let's just keep it down, 1/3 of 2x plus 3 raised to the power 3 over 2 minus, well, I'm just going to keep in 1 over 3 times. Now notice this is 3 halves, right? When we add 1 to that power, we're going to have 5 halves. We will divide this by 5 halves. That is just like saying multiplying it by 2 over 5. Okay, we multiply it by the coefficient, the 1 over the coefficient of x, that will be 1 over 2. All right, and then we are going to put what we have inside, the 2x plus 3. Then we add 1 to this power, which is just going to be 5 halves, right? Good. That is going to be from the integral of the function. But then here I'm just going to add an arbitrary constant, which is the constant that was needed, right? Of course, whenever you're doing indefinite integrals, you don't forget the arbitrary constants. Good. Great. So let's see if we're going to have something of this form. The constant, we have it here. Then this term, wow, that makes sense. But not really. Did I multiply this with x? Oh, this is supposed to be times x. I missed that. Let me put x here over 3. All right, so check that out. Okay, multiply that with that term. That was x, right? Good. So this is going to be x over 3. Okay, 2x plus 3 raised to the power of 3 over 2. And now let's see, this and that will cancel. We have negative 1 over 3 times 1 over 5. That is just 1 over 15, right? And then 2x plus 3 raised to the power of 5 over 2. And of course, the arbitrary constant. Okay, and this is very nice. This is very nice because if you compare it with the form that was needed, we have the constant terms. We have x over 3 times this inside here, all right? We have negative 15 over times that. That tells us that this inside ax plus b is what we have here, which is exactly the same thing as what we have here. So as you can see, that means that a from that, a will be 2, right? Isn't that nice? B will be, b here is 3. Okay, just by comparison. What else? C. Okay, C, which is the power of the first term, is going to be 3. No, here is 3 over 2. Here is C over 2. So C is just going to be 3, right? And then lastly, D. Well, D is just going to be 5. That makes a lot of sense, right? So let's see. The question is to evaluate A plus B plus C plus D. In fact, maybe I can just leave it for you here to evaluate this last part, right? And in fact, this is the main question that is being asked. So you are going to put this as your correct option, right? But the main thing is to make sure that your computation is correct and you get to their own form. Then you make your choice of constants and then boom, you get the result. So you're going to complete this yourself, right? Okay, that's very nice. All right, thanks for watching, and please subscribe to my channel.